Hello guys, welcome to Math2Go. Today we are looking into linear maps. We will look into the definition and also look at some examples here. Before we start, we need to take some field f, and you can think of the real numbers or the rational numbers. And then we need also vector spaces v and w, and you can think of the real numbers to the power of 2 or the real numbers to the power of 3, for example. So the common spaces we used in school also. So our vectors in school usually came from one of these spaces. And then the definition of linear maps is as follows. So definition: a map f from v to w is called linear if, so the first condition, f of ax equals a times f of x. And this must hold true for all a from the field f, so usually a real number, like 2, 3, 5, 7, minus pi, and so on, and x from the starting vector space v. Okay, and the second condition states f of x plus y, which is the addition within our vector space v, so adding two vectors, x and y, and this should be equal f of x plus f of y. And here we are adding the vectors, two vectors from the vector space v, w, from our vector space w. And this must hold true for all x and y from our vector space v. And what are two easy examples? So let's look at the first, which is f from the real numbers to the real numbers. So the real numbers are form also vector space over the real numbers, so over the field of the real numbers. And the map then could be like x is being sent to 2 times x. And you can easily see that both conditions hold, and we can also look at them. So here f of ax equals 2ax, and this is the same as a2x, and a times 2 times x is the same as a f of x. So the first condition holds, and for the second condition we see f of x plus y equals 2x plus y, and this is the same as 2x plus 2y, and this equals f of x plus f of y. So both conditions hold. So this was the first condition, this was the second condition, both hold. So this map is a linear map. Another example could be like f from the real numbers to the power of 2 to the real numbers to the power of 2, where now we have a vector of two components, x and y, and this is being sent to 2x and minus 3y. So in the same manner you can prove or observe that the definition, so both conditions hold for this map. So f in this case is also a linear map. And then you can write down further examples like f from R3 to R2 and here we have now 3 coordinates, and these are being sent to, for example, 2x minus y plus z and z plus y. We have here 2 components because our map goes into r squared, real numbers squared. So, and all of these 3 functions have something in common. We are not allowed to have products of the variables inside. Yes, for example, we don't have x times y or x times z. We are also not allowed to have x squared. So in future videos we will prove a lot of statements about linear maps. We will also identify matrices with linear maps and then calculate on matrices and all that good stuff. If that is interesting to you, please subscribe to this channel, leave a comment, like the video, and stay tuned.